Hello everyone. So today in this runtime generated world system we are going to work on this grass. So earlier we only had trees and the landscape generated. Now we are going to look into how to add grass. So now as you can see, I have demonstrated with these boxes, red boxes. So they are based on the player's location in the world. The world is divided into tiles, and as the player moves closer to those tiles, grass meshes are spawned there. We don't see that because that's happening in the distance, but that's what happens with these boxes, and I left them so I can explain it. So the reason I implemented that way, because if I spawn grass instances along with the terrain and these other big trees, it would cause a huge performance spike, because unlike trees we need to place a lot of grass instances. For that we will have to do a lot of calculations, which may be too heavy if I try to do it for all the terrains one time in the runtime as I generate the terrain tiles. So that's why I divided it into smaller tiles and generate them as player moves around. So yeah, this is what we are going to work on today. So this is a tile based spawning system will not be used just for grass spawning. I will be using as a base for spawning other stuff, such as maybe animals or maybe other stuff that we need to put in the world, other plants, a lot of things. So initially we will be using for grass. So yeah, let's see how to do this today. And also pay attention here, as the new tiles are added, you see a very little performance spike. So we barely notice a FPS drop as we move around and as new grass tiles are added. And before we get started, I'd like to remind you that you can download the project files of this project and all other thousands of projects that I have done in my channel. So once you become a member in Patreon page, you can download any project without a limit. To the date, there are over 1700 videos, and for each video project file is here, and that would help me to continue what I do in my channel. And let's get back to the tutorial. Okay, so this is what we have so far. So as you can see, we have trees where we can add multiple tree types if we want. So the only thing that is missing is grass. So since we are using procedural mesh, we can't use the landscape grass output. At least I don't know a way to use that with landscape grass output, because this is not the landscape component, as we need to generate it in the runtime. I couldn't use that. So what I'm gonna do is, just like we generate the trees, I'm gonna write another class to spawn objects. Then I'm gonna use that to spawn grass. So, but I'm not going to add grass as another type of a foliage here. I can do that, but if I did do that, then unlike trees, grass needs to have a lot of higher density. So I will have to do so many line traces to cover one tile of the landscape. So I don't think that is practical. For the trees, that's okay, but for the grass, I'm not sure that would work. And also we don't really have to place grass in all the tiles at the same moment. I only need to have grass in the area closer to the player. So let's start by add in a new C++ class using the type actor. I'll call it object spawner and create. The reason I use the name object spawner because I have plans to use this as the base class to spawn not just grass, other things also that we don't have to spawn along with the landscape tile. It could be perhaps other types of plants, so collectible stuff, or perhaps even animals also. Right, reload project. Now here we have object spawner. Now just like before, first step is having a tile system around the player. So for that, here let's start by adding variables. So we need to use this uProperty macro, otherwise we will not be able to use them in blueprints. So I'll use this. I'll use the category name spawn width. So int cell size. As the default value, I'll use 5000. Copy this, and here I'm gonna use square tiles. So cell size is both width and x and y. Int cell count. So this would be the number of cells in one direction. Maybe let's have 4. And we need to generate tiles around the player. For that, we need a way to know what's the player's tile is. So I'll add a function, function. I'll make it blueprint callable. So if you want, you can use this in blueprints as well. F vector get player cell. So this should return the cell that player is currently in. So I'll implement this. So there will be multiple possibilities. Either we can have a player character, or we may have a player pawn, or we may not have a player. Let's try this method. A player controller. Player controller. Get world. Get first player controller. And then I'll add a vector location equals player controller get pawn get that location. Now I need to know the origin of the cell that player is currently in, not the exact location of the player. So the cell means when I have this cell size, for now it's 500 cell size, 5000 cell size. So world will be divided into 5000 by 5000 cells, and we need to know which cell the player is in. So to know that, we can do this. I can But instead of calling this location, I'll just call this location, because it's not exactly the player's location. It's not going to be exactly the player's location. So location, I'll divide it by cell size, and then I'll reinitialize it with vector location no fmath round to end. So the reason I'm doing is because I need to know the cell. Location dot x, and basically we need to do the same thing for 3. See, y, and after this we just have to again multiply with cell size. So now we have the origin of the cell that player is currently in. So I'll return that. Location, that would be player's cell. Okay, now we have a way to access the player's cell. So then what we need to do is generating cells around the player's location, player's cell. So to do that, I'll add another function. I'll also make that low print callable void update tiles, and so here all we need to do is generating a set of tiles or cells around the current location of the player. So first thing we need is the origin or the center. So vector origin equals get player cell, and then to generate tiles I'll run 2 for loops int y. So y should start from this cell size, sorry, not size, cell count multiplied by minus 0.5, and should go until cell size multiplied by plus 0.5. or equal. That's why x also same, because we are having square amount of tiles. Starting from here and end from here. And now let's add another variable, vector tile origin. I'll call it tile center because we have origin here. This is the origin, means this origin means the origin or center of all the tiles. So tile center equals origin plus vector. So x multiplied by cell size and y multiplied by cell size and 0. No, well, actually we could do this also. This. So to check if we are getting the correct locations, let's draw debug box, get world, and then center, that would be tile center, and then extend f vector cell size, no, 1 1 1 multiplied by cell size multiplied by 0.5. That's the extent. And then color, f color, let's say red, and then persistent, it doesn't have to be persistent, so I'll make it false. And then how long? Maybe 20 seconds should be enough for us to observe. Let's save. And one more thing, to test this we need to call this update tiles from somewhere. So here let's call it from the take, but I'll set primary at tick and tick interval to, let's say, 3 seconds. It doesn't have to call in every frame. Then here update tiles. Alright, compile. Compilation successful. Now here is subject spawner. I'll create a blueprint. Here all classes. As the parent, I'll choose the subject spawner. pp object spawner. Okay, now I'll just drag and drop it into the world. Hold on, I'll place it here so that I know where it is, but I can easily find it here too, just no good reason. Right, now let's see. Okay, we do see a set of boxes, but that's not in the way I expected. Let's see. Cell count, cell size 5000. Sorry, it should be cell size, not cell count. Yeah, now you see we got boxes. Okay, one more thing. What if I simulate without play? And it crashed. Yeah, it's in get player cell. Alright, so I know the issue. The issue is when we simulate, we don't have a player, character or a pawn. So let's do it like this. We have to player equals player controller get pawn. So if upon react, okay, well, if player is valid, we can use its location. So I'll define this location variable in the beginning. Vector location is vector 0. Yeah. Okay. Location equals player vector location if we have a valid player. If not, it will be 0. Compile. I had to run again because the engine crashed. Alright, we have the object spawner. If I simulate, it should be generating around the origin. So that means around here. See, here we have the tile set. So cell count is 4. 4 divided by 4 multiplied by minus 0.5 means minus 2. So we are starting from minus 2, minus 1, 0, 2, 1. So the number of cells we get is correct, but it is always higher than 1, higher than the given count plus 1. So it's always given count plus 1 because of this integer, and that's fine. That's not a big deal. So if I play, yeah, it still works. Now you may notice the importance of using the cell system is because even the player moves around, the cell location does not change. So only if player moves here, now you see additional tiles are rendered, so generated away from the player, but still it maintains the overall grid. So that's the reason I implemented this cell based tile generation, so that for each cell or each tile we can generate or spawn whatever the things we need. In this case, the first thing we are going to spawn is grass. Okay, what's next? So here now we are just using the player's location and cell and using 0 for Z. So instead of doing that, we need to spawn stuff on ground. For now I'm not planning to generate anything on air, so generating stuff on ground is enough. So for that, let's do a line trace. Hit result hit, and then we need F collision query parameters. Put some params. So here we need to avoid hitting player. So for that we can actually use the same thing we used here. This approach. Oh, not cut, copy. Collision params and ignore actor there. What else? Then we can do the line trace. So let's get the hit result boolean as be hit get word line trace angle by channel. So first thing we need to give is hit and then start position tile center plus I'll add a parameter here. I'll call it trace distance. And then tile center plus f vector 0, no, f vector up vector to trace distance. Oh, maybe we don't need this. Okay, that's the starting point, and the end point should be this. Instead of plus, it has to be minus. And the finally, not finally, the next one is what collision channel. I'll use visibility and then collision parameters, and that's all. Alright, now if we get hit, if we hit, then let's draw this debug box. So instead of tile center, I'll use hit location as the origin of the box. Now we should see all the tiles on ground. Right. See? The tiles over there are above ground. Alright. Now, does it crash if I simulate? It doesn't. Good. Okay. Now, let's add another function to draw not tiles, sub cells within these bigger cells so that we can place objects like grass on the surface. So here let's add another function. I'll call it void update tile, and I'll give const vector tile center. Okay, so here this is where we generate the subcells of within those bigger cells. And one more thing, so since this is called in tick, if I don't have a way to track which tile is already updated, which is not, it will be updating all the tiles around the player in every tick, which we need to avoid. So to avoid that, I'll add a T array here, and the type of f vector I'll choose F vector 2D instead of F vector because we only need to track X and Y positions of the cells, because they are, maybe, I'm not sure, what if for some reason Z is changed because we are getting it from the trace. It should not happen, but what if? So spawn tiles, right? And here, before we do this, we can check if spawned tiles contains this tile, which is tile center. We need to give F vector 2D. Tile center dot X and tile center. Oops, what's happening? Dot Y. And yeah, if not it contains, then only we should update the tile. So to indicate that, I'll add the draw debug box and call this update tile. Here as the input I'll give hit result, not just hit location. For now nothing happens here. Let's see, let me reduce this to 5, and so we can observe as we move further away if the same tile is spawned again and again or not. It should not happen. Okay, so these tiles should disappear in 5 seconds. Did I compile? They're not going away. Why? Didn't I save this? Okay. Here we need to, if this tile is not contained within the spawn tiles, we need to add it. Spawn tiles, add F vector. Let me copy. Otherwise this will be always true. Okay, see, the grids are gone. So even if I move, they are not rendered again, but new tiles are rendered over there. See, so even if I come back, these tiles are not rendered again. Okay, so now let's see how to generate subcells, and we need to do that here in the update tile. First thing, so just like before, we need two for loops and y. So here we need another parameter, cell size. The next one I'll call it sub cell size. We don't need a subcell count because it would be derived from the cell size. and subset size. So by default, about 500. And then we can start from cell size multiplied by minus 0.5 and go until cell size multiplied by plus 0.5. And here, instead of plus plus, I will make it plus equals subcell size. And the same deal for x also. X starts with this. Ends with this, and increment with subcell size. So to verify if this logic is correct, let's see. Let's create a vector subcell location equals tile center plus a vector x y 0. Right, now let's set a draw debug line. Let's draw a debug line, direct word, and as the starting point I'll use this subcell location plus a vector up vector multiplied by trace distance, and as the end I'll use subcell location and color f color green. It doesn't have to be persistent, so false, and lifetime 5 seconds. Okay, now we should see lines within these bigger tiles if my code is correct. Okay, it seems correct. So let's do an align trace and find the exact location on the ground within this subcell so that we can spawn whatever we need to spawn there. So just like here, we can use this. Maybe we don't need to consider the player location here because we are going to have a number of line traces anyway, so missing one or two would not really matter. Okay, now I'll define this outside, and then the ball we hit as well. Now here we hit equals get world. Well, why don't I copy? Alright, now tile center. Do we have? Yeah. And here, if we get a hit, then let's do this subcell location. So here, instead of a line, yeah, a line is fine actually, but I'll make it shorter, like 100, so that we can clearly see the location it hit the floor. And I'll leave it a bit longer. Right. I didn't compile. Okay, here actually we don't now we see it doesn't look right. They should be on the ground. Why are they not on the ground? Oh, sorry, we didn't use the hit location here. So we should use hit location, not this hit location. But still, maybe for the first time, for the first set of tiles that we generate, we may not get the hits. Because, see, because why so little? That's only one. Okay, so to see the places that we don't get the hits, we can draw another line with a different color. Here I'll use tile. Oh no, silly mistake. Here we should not be using tile center. We should use this subcell location. Undo that. How did I miss that? So subcell location should be here. Instead of tile center, we should use subcell location. And then here, hit dot location. That should be the mistake. We have to be careful when we do copy paste. Right, now it's correct. But you see, for the first tiles, it's all horizontal. But other tiles, we get correctly on the ground. As I said, the reason is the reason is initially when we try to do the line traces for this object spawner, the ground tile is not generated. So perhaps to prevent that, we might do something like this. In this blueprint, full blueprint. Here initially I'll leave start to tick enabled false and then have a delay, let's say 0.4 seconds, that should be enough. Then set actor tick enabled to true. Yeah, now it's correct. I'm sure we can do that in C++ level as well, but it would be a little complicated there. Handling such things in blueprints like delays is really convenient within blueprints. Okay, the next step is placing foliage. But as I said, this will only be a base class because I need this to use I need to use this as the template to spawn various things, not just grass. So therefore let's do something like this. In here let's add a u function. Of course it has to be blueprint callable. Virtual void spawn object, and here let's pass const fhit result hit, and of course we can implement it within this function as well, but I don't want to spawn anything here for now. So another C++ class, and as the parent I'll use spawn object spawner. I'll name it cross spawner. And create, compiling, reload. So just like in this world generator, now we need to use this foliage types and foliage components. These two variables we need because I'm going to use them to spawn grass. So I'll copy these two. The content type. Let me close. Sometimes when the project is reloaded, this happens. I can't type. Okay, open again. Yeah, all right. Yeah, now it works. Public. Right, I'll call this as grass, and maybe not necessarily grass. We don't need a category here because I don't think we would have anything else in, or we might need, because yeah, I'll keep foliage because this is a child of object spawner, and in the object spawner we have this spawn grid related stuff. So in order to use these, we have to use this header which contains information about foliage types. Okay, and in order to use this we need to have this foliage dependency added. I have already done that because I have already used it in world generator. So the other thing we need is this instance static mesh component. Okay, I'll add that too. Now let me save and recompile. Okay, now here I'll add another blueprint class and I'll choose class spawner as the parent. Let's call it pp class spawner. Now here you see foliage types. So we for now we only have these trees. So I will create a foliage type. I have actually some grasses. Static mesh foliage, FL grass. So I'll assign this static mesh. So for now, one 1.5. For now, let's not worry about these all other parameters. Now let's assign FL class, and in order to use it, let's add a function initialize foliage types function, not even graph. Okay, now get foliage types, and for each type I'll add instance static mesh component. Promote this to a local variable. I'll call it ISM, and then I'll set static mesh from this get mesh. Okay, and I'll put this ISM into we can get foliage components which we defined over here. I'll put it there. Okay, now I'll call this function here initialize foliage types, and also we need to do this here as well. Then I'll set this to false because we need to wait until the landscape is initialized before we try to place any foliage. So let's go back to C++, and here we need to override this function, this one. Because it's a function. Alright, okay. Now let's define the function here. So here we get the hit result. We can run a for loop int foliage type index foliage components. No, foliage, yeah, components, that's fine. So each foliage component we are going to add an instance. So I'll define a f transform. I'll call it instance transform. For now I only have one foliage type added here, so no overlapping will happen, but eventually we will look into how to handle multiple types as well. F transform and instance transform. Oh, not here. Transform set location. I'll choose hit location. Yeah, and instance transform set rotation. I'll choose F rotator. Zero, zero, F math. So I'm just randomizing the rotation. Rand range something between 0 and 360. To cool. To cool. Oh, we need to close it here first. Criterion. Okay, and scale. Set scale 3D. Factor 1 1 1 and multiply it by, I'll just multiply this with a random number. Rand range something between 1 and 1.5. And then foliage components, get the current one with the foliage type index, add instance and give instance transform, and it should be world space, yes, so true. Alright. Is that all? I think so. Let's try. Now we need to replace this object spawner with grass spawner. Replace it grass spawner. Okay, let's see. Nothing happened. Did I call a spawn object actually? Oh no. Okay, so let me Okay. What's right, I know what's wrong. Here, actually the second one. When we set rotation, the second one is yo. Yo pitch, yo roll. So that's why. Okay, now you see we have grass, but you can see they are on trees as well, and they are in a grid, which I don't want. So, and also I'm pretty sure they have collisions as well. Yeah, but this is a good starting point. Now we can start working from here. I think we have another grass mesh. Let's first see how to get rid of that pattern. So we need to give some randomization, some random offset. We can add that here. Subcell. I'll call it subcell random offset. So I'll make it the default value maybe 200. Then here, when we do the line trace, to this X I'll add fmath and range minus subcell random offset to subcell random offset. I'll give the same value to the same addition to Y as well. What's wrong? Let's use front range. Oh yeah, because it's not a float. Now we should not see the clear grid. Yeah, it seems better. What's next? And it crashed. I'm gonna find out the reason now. First, let's fix the collision. I don't need collisions for this. So I'll set no collision here, and also then let's fix here. If I choose the subcell size, so smaller value, now we see a lot of density. Now let's see how to prevent spawning them on those trees. So for that, here we can check if it's physics material surface. How to access surface? Get surface type. This is 𝐒𝐵𝐵𝐵𝐵𝐵𝐵𝐵𝐵𝐵𝐵𝐵𝐵𝐵𝐵𝐵𝐵𝐵𝐵𝐵𝐵𝐵𝐵𝐵𝐵𝐵𝐵𝐵𝐵𝐵𝐵𝐵𝐵𝐵𝐵𝐵𝐵𝐵𝐵𝐵𝐵𝐵𝐵𝐵𝐵𝐵𝐵𝐵𝐵𝐵𝐵𝐵𝐵𝐵𝐵𝐵𝐵𝐵𝐵𝐵𝐵𝐵𝐵𝐵𝐵𝐵𝐵𝐵𝐵𝐵𝐵𝐵𝐵𝐵𝐵𝐵𝐵𝐵𝐵𝐵 Let's add a property here. This a physical surface. Surface type. Can we compare it? Okay. I'll rename this to supported surface type. Okay, now check if we have the supported surface type we defined here. If not, return. That means we don't do the rest. So now save and compile. Build failed. You can't use it has to be like this. Is it working here? Yeah. No. Okay, so to successfully compile, I had to add this physics core module into build.cs file of my project. So now it compiles properly. And after compiling, here you see supported surface type. It only have default because under physics we only have default. So here terrain, or maybe not terrain, ground. I'll mark as ground. Now we have ground, but now it crashed. Okay, let's try again. Need to recompile. Here, ground select, and it crashes. What's wrong? Grass spawner CPP8. So this is a problem. Maybe because this doesn't have a surface. Let's see if it dot basics material. We need to first check if it does have physics material. So I did this. Now let's put this also inside. Compile. It's not crashing. Okay, but it's also not spawning anything. in the world here. Yeah, it doesn't have a physics material. So let's assign one first. PM terrain. Here as the surface type, I'll assign ground. Save everything. Right, now let's see. I remember there is a flag to return physics material. Here, collision params be return physics material to true. Now compile. Yeah, now it's working. See, no more grass on trees. But this grass does not look very good. So, and also it does not blend in the distance too. So, do I have another grass here? Oh, this one. Cross MS because mega scans. Okay, let's see how it looks. Oh, I didn't change it. That's barely visible, but it's there. So we might need to increase the scale. Here, let's use this now. I'll say 45 and but I can't use it yet. Yeah, here I'll just use 4 now. Scale 4 to 5. I'll properly implement using the actual parameters later on. I didn't compile. Yeah, see, it blends properly. Okay, that's much better. And we obviously have to make it align with the surface. Other than that, it looks alright. So also, let me name stat graph. So we can see as the new tiles are added, is the performance lag. That's fine. We barely notice anything. Alright. So I think it's good for us to stop here. In the next time we will look into further improvements of this. So like using the actual parameters that are available within foliage types, like scale and what height range, what ground slope that they should be spawned, things like that. So we will look into them in the next episode. For now, I'm gonna stop here. And also we need to look into like how to remove instances if needed, how to remove instances from tiles further away, so that might help us with performance as well, just like we do for trees and landscape tiles in generating world. Alright, so thanks for watching. As always, updated project files will be available for the download in Patreon page. Link would be in the description below, and see you in the next episode. Goodbye. As always, feel free to let me know what else suggestions and what else I should be covering in this series.